unit circle. The unit circle means the radius of the circle is 1. So that's what we have here from 0 to 1. And the quadrants here in Cartesian system are 4 quadrants. And the first quadrant is from 0 to 90 degree. Just let me mention this. We already know in the circle has the interior angle for 360 degree. But the first quadrant here is between 0 and 90 degree. Second quadrant of the circle is between 90 and 180 degree. The third quadrant is between 180 and 270 degree. And the fourth quadrant of the circle is between 270 degree and 360 degree. But in this picture here is represented and with the radians, with the pi, for example. For example, the first quadrant is from 0 to 90 degree, but here is from, in terms of the radians, we have from 0 to pi over 2. And if it's 30 degree, we have a pi over 6, 45 degrees pi over 4, 60 degree pi over 3, and it continues this process. But now the point here, for example, in each point, is the first coordinate signifies the sine x or theta, and the second one is the first one is a cosine theta or x, and the second one, the second coordinate signifies the sine theta or sine x. But let's go here and see different picture. In this picture is much better is presented. So x here signifies the cosine theta, and this y, the y coordinate, signifies the sine theta. And this point here, xy or cosine theta, comma sine theta. So this way we can present in the circle the trigonometric function. Sometimes this function, as I said before, we call the trigonometric function, elementary functions, or sometimes they call the circular functions. And let's see why. For example, if we have a function y is equal sine x, how do we get to this graph of the function? This graph of the function we get by unwrapping the unit circle. When we unwrap this unit circle, and sine x, if a sine x is equal to 0, you plug in the calculator and you can verify is a 0, the sine of x is a 0. That's why it starts from the 0. And this distance, as I said in the beginning, the vertical distances in the circle here signifies the trigonometric function sine theta. So this is sine theta and is presented right here. It here is projected in the function. And this distance here is very, very closer to the 0. This distance here is projected right here, what I am pointed with the mouse. And now if you look at this distance from this point down is very closer to the pi over 2. So it's very closer to pi over 2. Pi over 2 is right here. And this distance here is presented right here. Is projected here in this position. And pi over 2 is from 0 to 1 because radius is from 0 to 1. And this pi over 2 is from here to 1. So it means that this interval is from 0 to 1, is up to here. And now, as you see, this was the first quadrant. And second quadrant, when start, you see second quadrant, this distance here is projected right here. And it goes, and pi is in 0 here, up to 0. And is the second quadrant, between second and third quadrant. That's where is a pi. And now, if you look in here, the third quadrant goes down, and this part you see goes down. And this distance is projected right here. And 3 pi over 2 is a minus 1, because it's 1 unit. But because it's 1 unit, and this is a 0 and minus 1 is right here, the point. And here is 1 unit. Is 1 unit down. And then now, this from this distance to this here we are called the amplitude of the trigonometric function, and this amplitude is 1. And now that cycle, what we are doing from here, from 0 to 2 pi. 2 pi is right here. And again, when we see, for example, when we plug a sine of 2 pi, we're going to see in a calculator is 0, or if we are setting up the calculator in a degree, we can plug in a 360 degrees. Sine of 360 degree is a 0, is right here. And this cycle is going to be repeated throughout the whole the x-axis in a positive direction and negative direction, and that signifies the function y is equal to the sine x in Cartesian system. But now let's go and see the cosine x. How is created the cosine x? Uh, Again, we have the unit circle, and as we said earlier, the cosine x is in the x-axis, in this direction, is right here, this point, this distance. And when we wrap here the circle, first of all, we are plugging here 0. And when you plug in a 0, cosine of 0 here, and you can check in a calculator, it gives you 1. That's why it starts the graph of the function from 1, starts from this position here. And this distance is projected right here. And now, but this distance here is the same like this distance here. So there I just want to make a little this point, and I think it's a little bit more difficult to see how it's projected, but I will try to make much easy. And now, okay, I got this. And now this distance is projected right here. And now this 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 distance where is projected. You see, it's a closer to pi over 2, and this distance is a closer to pi over 2. You see this distance here? Exactly this distance what I'm drawing here, this distance is projected right here. And the other distance, you see I'm going very closer to the pi over 2. And this distance here is projected right here. And in pi over 2, this point here is 0. And if you look, for example, and you plug in cosine pi over 2, you're going to get a 0. And that's how is this graph. And now we are going in cosine. This side is a negative side, so x-axis are negatives. That's why the quadrant is going to be negative. And now this distance here, for example, from here to here, you can check, or we can write it with a different color if we want. Let me write it with a different color because it's a different part. And this distance here, we are moving a little bit further than pi over 2, and we have this distance. And the other distance is this distance from this horizontal distance, this is a cosine x, is right here. And the third one heated with the blue, is done with the blue. Let me make it with the blue color. And this with the blue color is right here. And pi, here is a pi. Pi is right here. This distance, the longest distance from 0 to negative 1. And that's why it goes in a downside to minus 1. Here is minus 1. Here is minus 1. Here is positive 1. That is the amplitude of the function cosine x. And this distance from here to here is 1 unit. And again, when we go into 3 pi over 2 in this quadrant here, is going to be equal with 0. If you plug in the cosine 3 pi over 2, gives you 0. If you plug, for instance, 180 degree or pi, you're going to get minus 1. And that is this distance. And this continues. And this goes in a fourth quadrant. The fourth quadrant, you see, is in x is a positive, and the cosine theta is in a x direction. That's why it is a positive in the fourth quadrant. And now, if you look at, for example, distance from the pi over 2, from 3 pi over 2 in direction to 2 pi, it goes this here, this distance. This distance is projected, right? This distance we project in the function in Cartesian system right here from the circle into the Cartesian system. And everything all the distances. The longest distance, not this distance, for example, this distance here is projected from 0 to 1, and here from 0 to 1, and this is the amplitude here from 0 to 1, and this is one period of the trigonometric function y is equal to the cosine x, and this cycle continues throughout x in direction of a positive x-axis and negative x-axis, and signifies the function y is equal to the cosine x or cosine theta.